I will I will turn the floor over to Frank.
Thank you, Aaron. And I want to double down on Aaron's thanks for everybody who pulled this together. This is my 14th HFIP annual meeting. It's I think one of the best meetings that I know of to deal with it from our community on the operational research intersection. So first off, we want to talk about the strategic goal planning. For those who might have been around as long as I am, we started with a strategic plan, first one in 2009. Not the plan I talked about. This was actually a strategic plan. And then we set out our goals and laid out a strategy, key points that we had to address. And then we updated it because it was we were charged with not only improving things in 5 years, but in 10. And so when the Weather Act was passed in 2017, we took the same strategy to put together the next 5-10-year plan, which was the one that is on the website at the HFIP. So we're going to go through that first and see, because it's time for us to think about the next 5 years. What are we going to do? Reset. So the 2019 goals are here. The metrics are in the appendix, very detailed metrics, thanks to Mark DiMaria and James Franklin and the NHC folks, Mike Brennan and others. They laid out very clear deliverables and metrics for each of the goals that you see here. So first one, reduce track and intensity instruction forecast guidance errors by 50% in 10 years relative to the 2017 baseline. And those baselines aren't plotted, unfortunately, but they're listed clearly in the appendix, and we'll work to plot those up. But reduce intensity forecast errors by 50% also in 10 years, including RI events. That was a biggie. And I know that Mark and James and a number of us struggled to make sure that goal was and the metrics were clear because RI is such a rare event that we decided that we would take it on both bases so that we make sure we captured both. And I don't remember if we got a report out on where we are on RI, except for the bar charts, but we're doing pretty good. I was pretty surprised. We're well on our way to that 50% goal. The second one was produce 7-day track and intensity forecast guidance as accurate as our baseline in 2017 as well. Now, I know on track, we're pretty good. We're almost there, I think, in 5 years. But we had a blip this year, which probably will change that a little bit. So we have to rethink that. And the intensity goal is going to be a stretch for sure at 7 days. And this is really mainly to inform NHC's desire to go to a 7-day lead time for their customer like DHS and others that need these longer timelines. Then comes the guidance on pre-genesis. We heard a lot from NHC about we'd like some more help. I mean, Lisa gave a nice talk about now they're providing 7-day tropical outlooks on Genesis. But she also said that they need some help on that because they're, they have a product now, but we need to do more to help them with that. And in pre-Genesis was picked, or pre-formation, because what we want is to get timing and location of Genesis, not, guidance on that. And I think we're on our way there, but as we heard from Lisa, there's still issues we have to address. And then comes the biggie, the one that I think really is the one that's going to be our biggest challenge. Improving hazard guidance and risk communication for all TC hazards. The Weather Act called out storm surge because it was the biggest killer. But I think it has to be for all hazards. And at actionable lead times. We heard from Jamie that NEC is now doing surge, they're going to do 72-hour lead time. We also heard from the Lee County Emergency Manager, they want more time. And so actionable timeframes, right now we're at 48 hours. So a lot of our goals that we've been evaluating in the bar chart you saw, we're targeting that 48-hour lead time. So we need to think about that, you know, as we move forward. What are the actionable lead times? What is the customer and NHC need us to go to as we think about these targets? And of course, you heard about the social behavioral science aspects, and just Showers talk about the tropical roadmap. How do we map those recommendations onto our products? This is going to be a big area. It's very different than what HFIP has done in the past. And I think we need to think about it too as we develop our next strategic plan and target our specific needs. Yes.
I just wanted to comment on that last slide. Something that I think we really need to think about is if there's any way we can assign either numbers or some sort of, you know, actionable or quantitative goal to number 4, because right now we look at 1 through 3 and we can say, okay, we've met those goals. The 4th one, it's a bit more ambiguous. So.
No, it's not. If you look at the appendix of the strategic plan, they actually listed targets.
Yeah.
So we need to put those up front, but they're in the appendix. They were developed by our operational folks to be reasonable, but they're notional. We should revisit them. I agree, Will. They should be revisited and called out, because I think this is going to be a major effort in the next 5 years. And so whoever wants to be involved in the strategic plan development, and, you know, we need bodies from the community, young bodies, not us old folks, to help us do that. So I want to get on to the next. So in the 2019 plan, the way we developed, we had those goals. How do we do it? And so we had 6 key strategies. One was HAFS, to advance HAFS. Okay. Well, we have HAFS right now. We have a V1. What's our big bottlenecks right now? Okay, the performance there, and I'll talk about that in the 3rd slide, what we heard from our operators this week, our needs. But the big one that struck me in the head was the HAFS JEDI transition. If GSI is going away, this is a major push. And, you know, Darrell gave a very impassioned plea that, you know, he needs help. And I think my recognition is, from our community's perspective, we kind of react to that, but we need to be more proactive. And I'm going to suggest something at the end after Gopal goes through some of these ideas that we have, what we need to do. The second is improve probabilistic guidance. This is a biggie too. We heard a lot. Mark talked about TC something, TC, and then we heard about DESI, and we heard about a lot of these machine learning things. And then we heard a great talk from Wallace today about the WTVC or TCV or the WIN model. And it resonated with me, because that strategy, and then adding what Mark talked about in the machine learning to that, is, I think, a pathway we have to take. And we need to quantify these metrics so that I want to get from the operators what they would need. I mean, I think Mark gave us a nice outline of those things, but we didn't talk about rain. He talked about gust, he talked about wind, he talked about track, but we got to talk about rain. And I know we can do rain because Mark and I have already talked about it. So I'd like to see that added into the mix. We talked about reanalysis. Now, reanalysis to me says DA. So to me, reanalysis means we got to do the JEDI transition before we think about reanalysis. But we ought to start planning for what that would mean. You know, is it going to be HAFS VX and with JEDI or whatever? But we need to do a little bit of work, I think, there before we jump into the reanalysis bandwagon. That's just my perception. Obviously, machine learning as well. All right, communication of risk and uncertainty was the third key strategy. We heard a lot about the triangulation. We got great talks from Castle and our stakeholders about what they're looking for. And we heard Jess talk about the tropical roadmap. I think we need to work the tropical roadmap picture into this next 5-year plan. How are we going to actually do it? Jess, I think, has some good ideas. I don't know that she's got the support from us yet that she needs to get that moving forward, but it kind of links to the probabilistic guidance. I think they're linked together. And so as we do the products for number 2 strategic goal, it's going to impact what the social behavioral science, how we link that. You know, I heard scenarios. How do we do scenarios? Can we do scenarios? And I think we can, Mark, through things like cluster analysis and stuff like that in our machine learning approaches. You know, how do we tease out possible branching? In simple forecasts, maybe it's easy, but in a Philippe messaging, that would be very difficult, as you pointed out. We heard a lot about HPC. I think Radhika and Frank gave us a really good picture. I would say that's not as much of a challenge maybe moving forward, although we need to make sure we protect our interests and get the resources we need, particularly given some of the ideas of ensembles and things like that. R2O enhancements, EPIC is now a big player. This DTC EPIC transition, this is something we got to navigate. We hear about containerization, and we hear about, you know, besides just working with DTC to support our training, the training modules they've done on HAFS, all that material, is that going to get translated over to EPIC? We need to figure that out. We need to have a strategy there, because we don't want to lose the community we have, and we want to actually increase the capacity. And then, of course, broadening expertise and internal interaction with the external community. I think EPIC is going to be a place we're going to have to look. UFS and UFS R2O are obviously our bridge into some of that, but we need to refine that. Those were notional when we wrote the 2019 plan. They're now physical entities we have to react to. So those are kind of my thoughts. The last slide I'll talk before Gopal goes is what I heard. And maybe this should be a topic of discussion, but these are the issues I heard that came out from the presentations on that first day, particularly. That on intensity, we had some issues, and particularly in Otis, in my mind. Those were the 2 biggies. You know, there were issues that were, people said, hey, maybe we need to look at the VI, maybe we need to look at the GFS, maybe we need to look at resolution. So these are things that we need to tease out because they're going to inform our HAFS developments in the future. All the high-res models missed Otis, RI. Otis and Philippe, I'm not dissing Philippe Papin, but Philippe and Otis, I don't know any Otises, I do know Philippe, they stood out. And so we have some ideas, we have some testing to do. I think that's important. Interestingly, on intensity, HMON was best overall. I heard a couple of people say, well, maybe they were all weak systems and HMON does good on the weak system. Who knows? That's a comment. Let's show proof. HAFS A was worse in the Atlantic on intensity, but best in the East Pac. Okay. HAFS B was best in the Atlantic. You know, there's all these different things going on. Diversity is something we have to address. Right now, we're looking at diversity from physics. I want us to think about diversity in initial conditions. We heard from Stephanie how uncertain their ability is to assess the intensity, particularly weak systems. And we also heard that one of the areas where HAFS A and B are different is how they treat when to turn VI on and off. this is a potential area of interest that we need to tease out and understand as we move forward. One thought I had was, let's start HAFS B with a different center, do vortex relocation at a different grid point, and see whether we get more diversity. I mean, that's almost trivial. Yeah, okay, let's just shift it to grid points and see what happens. Because one of the things I think we learned from HWRF, we get more diversity from initial conditions than we get from physics changes. So something to think about. Hillary and Idalia, wow, we did great. They were simple. Okay, we take those and say, okay, good. We got what we expected. It's the, as Naomi used to call them, her busts, which is a bad pun, are the ones that we learned from. And I think so Philippe and Otis are going to be something we really have to spend some time thinking about. On track, Philippe, right by us, drove poor seasonal track performance. We heard that many times from John Cancelucci. Track, worse for weak and sheared storms. Is this the VI issue? How can we deal with these weaker systems? Some of it has to do with initialization, some of it has to do with the GFS. Overall, HAFS A and B better than GFS. That was very interesting. And Fang Lin and I chatted about this, and it tells me, and Fang Lin agreed with me, that we need to work more with the GFS folks. We've been reacting to GFS all this time. I think we need to work more closely together on changes that we do, because GFS, we're all driven by GFS. And if they do things and we have to react to them, we're catching up. We're 6 months behind by the time, we really know what's going on in the season. So I think we need to work more there. Hillary and Idalia forecasts were very good. Okay, yeah. Structure. This is something that I think we've talked about, and Tim and I have been discussing this. R34, we have a high bias. It persists. Is that a diagnostic issue? Is it a model issue? Are we comparing eggs and apples or oranges? We don't know. Hurricane Center, I'm going to call you out a little bit, because we talked about, Tim redid the tracker. Has anybody done an analysis of how the tracker performance agrees with what you guys call your R34? And, I'm going to be particular that each hurricane specialist kind of does his R34 a little different in operations. Now, when it comes to best tracking, I think it's okay. You've got a clearer definition. So I'd like to call you guys out a little bit to do a little internal looking to see if what you call R34 is the same as what the modelers are calling R34. Tim has done a lot of work to try and deal with outlying, convective bubbles and bands that aren't really in the R34, but we don't know how good that is with what you guys do. So a little more formality in defining those things so that Tim and you we're comparing apples to apples and not apples to something else. And it was interesting. RMW, of course, we expect that to not have a high bias because of the resolution, but it's still something that's important for the storm surge group. We need to think about that. If we're going to generate uncertainty on RMW for the storm surge or for the wind speed probability to give you guidance, we just remove the bias and give you the PDF, probably will be okay. They'll give you the uncertainty, but we need to think about that. So I'm going to stop there and let Gopal take over on moving forward.
Yeah. Thank you, Frank. Yeah, I've been following Frank almost for the last 14 years because I remember being hired in AOML HRD for doing HFIP. And then subsequently I took the developmental leadership after 4 or 5 years in 2014. So been doing it for about 9 years. Wish to thank everyone for the support through thick and thin. Actually, the group has expanded, and every year I keep saying that this is the best meeting. And this year, yes, definitely it was the best meeting I have been in. And thanks for everyone's support. Not only here, but we have been running seminars every bi-weekly or monthly. We started bi-weekly and then monthly, and then we have people coming up and saying, "Hey, I want to share my work." And please, we welcome everyone here and the community out here. Please do reach out to us if you have any interesting work. Please share it with us. We'll continue with Great Forever, which we have done in improving forecast. With that said, can you go to the previous slide? Yeah. The first one that I wanted to mention was, yes, these issues Frank has already mentioned. Wanted to make sure that, yeah. Oh, thank you. Thanks for letting me know. We want to make, because I might go around the room most of the time, we want to make sure that we address some of these issues basically, and how we are addressing it. It is going to be useful for both EMC as well as the forecasters, so that we can improve the HAFS system. And I wish to spend about 5 minutes because you have gone over this. And if there is a plan on how do we go about in addressing these questions, basically, any inputs on, do we want to develop a plan, or any inputs from anyone here?
Some of this, I think we find the issue is the first order we need to do. Then we find a solution. At this moment, we, especially like Philip, we don't have a solution. Otis, we don't have a solution yet. But I would like everyone stay, stay on those topic and present in the Hurricane Conference. And myself will also attack some of those problematic forecast. So give my solution, but I would like everyone here present their solution during the Hurricane Conference.
Thanks, Eugene. What we mean to say is we are initiating research in this direction, basically in most of the places. And any comments from you, Zach? Is EMC doing some of these experiments, and do you think that it will be helpful to work together on some of these experiments so that we get some progress?
Yeah, actually, from EMC side, we already started some investigations, like for Hurricane Lee, and we have, being already listed some of the case studies, experiment we have done, and actually currently we are looking at the ocean responses and also model physics. Basically, I guess for the Hurricane Lee, we have pretty good ideas how do we address the issues. But as Eugene mentioned, for Hurricane Otis and Philip, we do not have crews right now, and so we encourage it if we can have collaborate with HRD and other university and other research community. So and if we are expecting, we have some conclusions or tentative results to present at the next year's Hurricane tropical meetings, AMS tropical meetings.
Just add one more point. Frank list here Otis and Philip as intensity problem. I would say it's more track problem than the intensity. Before we fix track, we cannot talk too much about the intensity because
So you need the,
yeah. So,
Frank, you need the mic.
so that's why they needed a couple together.
Yeah, well, the thing about Philippe that I took away was HFIP did a heck of a job and HFS was terrible, and I don't know why. They're both very similar models. From the statistics you see, they're similar, but there's something different. It's VI, yeah, there's some difference in the initialization.
Yeah,
So actually with Felipe, Frank, I would say it had a kind of a bimodal behavior. So HAFS picked one mode and HAFS-B picked the other. Early on, you had other models also deciding on continuing this further eastward or turning it north. The only issue was at what point they start turning north or not. But it's a good point that, what was in HAFS-B configuration where we got it right. And
Yeah, can we make HFIP worse? Find out.
Yeah, well, I'm sure we can, but the better would be to find out how we make HAFS better.
yeah, I think we have questions.
Yeah, I just want to follow up on Avicha's point that actually we do notice that for Philip track forecast, and because we are also running the hurricane ensembles, you can see there is large uncertainties. I mean, the spread is huge, so which indicate could be the predictability issues.
So,
So just for HFIP, just by chance, it just didn't pick the right track.
If that was, wait, hold on. If it was just by chance, then you would have seen random stuff. HFIP was systematically better almost every cycle. Like, we have a ton of data. Like, yeah, we flew. Like, I don't you can go back to my slide. I think the answer, I'm going to do more work on Philippe. Daryl asked me to do some work on it, but I think the answer has a lot to do with how HAFS A and HAFS B are different in the
questions
initialization.
coming from hybrid. Yeah, there are two more questions before we move on to the next. After that, we can go to Joseon. One is Dave, and I think Philip. Dave, can you go ahead quickly with your question?
Yeah, thank you. Before we go too much into the future planning, I wanted to hear from Frank that while there was discussion about the time-based improvements, was there any perspective or metric regarding localization or spatial improvements in terms of the outlook? Thank you.
I can't remember that far back, Dev. I'll have to go back and dive into the strategic plan, which was a group of about 12 people. I only pulled it all together, so. Yeah.
So can you?
Yeah, I mean,
You talk.
we always feel that the track
Use
is
the mic.
critical to pretty much everything we do. So in terms of localization, Deb, I don't think we thought about that. We knew it had to be dealt with because impacts are always local.
Yeah, one more question from Philip, and then I'll let you talk. Philip, do you have a question? Remote?
Yes.
Great.
So all I want to kind of contribute just to sort of tie a bow on the Philippe errors for both track and intensity is that I think the reason why they were both so closely tied together is because the vertical structure was really critically important for both getting track and intensity correct. And I think part of the reason why HAFS-B was so much better compared to HAFS-A is that it correctly diagnosed that vertical structure that was going to lead to that very kind of slowly drifting low circulation well away, well removed and tilted from the mid-level vortex. And so I already kind of put a comment in the messages already here, but I think this was a case where the aircraft data substantially improved HAFS-B because it was able to correctly diagnose that vertical tilt that was so far kind of tilted down shear that it was basically stuck in this state where it stayed vertically tilted like this for several days in a row. And so models that were immediately trying to make the system vertically aligned were then taking it quickly to the north and intensifying it, like the GFS and even HAFS-A for many simulations. And so I think kind of going back to what we talked about on Monday, getting the structure of tropical cyclones is just as important as track and intensity forecasting. And the vertical structure in particular is going to be something that kind of, I think, helps improve model forecast going forward.
So related to that point, and we're saying like, okay, well, one of the models got the vertical structure. Forget about that. I would say just from not an outsider, I'm part of this community, but someone who doesn't dabble in the models all the time is, concentrate on what the physics differences are between the two models and what within the physics models would lead to one model not being able to have the correct vertical structure and the other one having it. You know, diagnosing what the physical reason is of why one moved one way is not it. Is it a difference in the PBL scheme, which tends to give you more vertical development versus the other one not? And then diving into that, that convective scheme of, well, what is physically different? So to Frank's comment about it's kind of depressing that one did it, one didn't. And I would say that that's encouraging as heck, because they're so similar that you can really isolate the physical differences within the schemes to then test them individually to see what the heck, is different and why. So I see it as a good thing, not a bad thing.
Thank you.
If I could just add one quick thing, and that hasn't been brought up yet with
closure quickly.
Philippe, is that there was also a binary interaction with Ophelia. So the intensity forecast of one storm impacted the track of the other. So that could be a case where a larger high resolution nest, which encompassed both storms or multiple moving nests, would potentially aid in the forecast. So
Yeah, Gus, last.
So to Frank's point on his slide, he was talking about how the performance is different in different basins. I mean, the performance is different within a basin. And yes, we should be diving into the models and finding out what's happening there. That is an absolute approach we should see through. But the other side is figuring out how we can provide better guidance on where the models have larger or smaller biases in track and intensity in the basin. I know in chatting with Wallace and other folks at NHC, they don't have a lot of guidance on that right now. So as we upgrade HAFS, I think we should be cognizant about how we can, communicate what those biases are and try to break those down within the basin, as much as we can realistically. I know we're limited by sample size, but we've been dabbling in this a bit at HRD, but we need help. So,
okay, with that, because in the interest of time, we need to move on. One of the take-home messages that I can get from the HFIP perspective is that as we progress with each of these problems, if you could share that in our HFIP monthly meetings, and of course, the final target will be the AMS meeting that Sujin was talking about. So if we can share whatever is coming out of this research, it'll really help, not only because this is, as you know, the seminar, the monthly meetings are something that NHC, AOML, everyone, the community sits down. Probably that's where we need to go, probably. You want to go?
I just want to make one quick comment as far as the HFIP monthlies go, just for reference. Because of the annual November, AGU in December, and then AMS in January, we're not going to have the next one scheduled until February.
Yeah.
Right now, I believe we have speakers scheduled for February and March, but if you have things you want to present to the HFIP monthly seminar, please reach out to me and to Will Kamari, and we will get you on the schedule. If it's one where you want to present for the whole hour, that's fine. If it's one where you want to present for part of it and have a discussion, that's fine. If it's one where multiple people want to present for part of the time, that's fine too. Thank you.
Yeah, if we can present the problems, current and existing problems, that may be very, very useful for HFIP. With that, probably, yeah, I pasted this.
Just one more point.
Yeah.
Is in my slide have LML website and EMC's website. Go there, dig into, tell us the problem. If you
Yes.
find the problem, let us know. If the problem, we find the problem, that's 95, solution already come. Rest is come up to the solution. Fine.
Thanks. Yeah, 2 websites are there that Sujin mentioned. Stan, last one from you, because I need to move on. Several slides are there. Go ahead, Stan. Stan?
Oh, yeah, go ahead. I mean, I finally just put in the comments. Just someone mentioned earlier, we got to get the track right to get the to work on the intensity. That doesn't always apply. They sometimes are totally different problems. And I want to sum up everybody's statement. It's complicated. We've got all these different things, and that's why a meeting like this is so exciting to see all the focus work on all these different areas. Some are more important for some storms and some aren't. We just got to keep working and juggling and getting towards a solution. Thank you.
Thank you, Stan. Yes, we'll keep working, and you have done this as well for HWARF will continue doing this. So this is taken from Avichal and all the developers basically. And then people have gone through this basically, and if I think I can quickly move on from here. And as Frank mentioned, JEDI is an elusive issue, which we will be discussing in the next few slides, just to put to people what priorities the modeling developmental team came out with. Basically, are these short-term, because we are only talking about V3, and the strategic plan. When we are talking about strategic plan, we can talk more about the future, like global nest and stuff like that. But now let's focus on the short-term plans. This is a 2-year plan, okay, that we are doing. So that will also help STI and the UFS as well, these plans. So that's where we are gearing towards. Any objections with this plan, please let us know. Otherwise, this is the developmental priorities we are putting together. The next one is JEDI specific. Yes, yeah, your inputs. Yeah, Zach, go ahead.
Yeah, so in your, yes, this slide. So actually the moving nest, the second bridge is very important for the flexible nesting refinement. I mean, right now for all these rapid intensifications, probably it's pointing to the model resolutions. So if we have these capabilities, we can further increase the horizontal resolution.
Okay, very, very important point.
Yes, so Otis, at least like so far, do the 3 kilometer uniform. It doesn't work. So now I'm going to do further refinement, and then Pinzu, she is working on the 3 TKE scheme. So we add that, have some kind of improvement, but not that significant. Probably still point to the resolution.
Yeah, Otis might be much beyond resolution alone. That's what you're saying. Okay. Well, nevertheless, yeah, flexible refinement. Yes, I hear what you are talking about, and probably mass adjustments. As far as I know, I had discussions with GFDL as well. Dell, May, and GFDL. It looks like that may not be an issue because because for mass adjustment we do back and forth interpolation between between the vertical one grid to the another grid, which we did in HWARF, and loss of accuracy is well taken there, whereas the GFDL vertical adjustment process are more conserved basically. So where we will gain something, we'll be losing something else. So that's a debatable item. Actually, mass adjustment we can talk later on. I've had meetings with Bill as well as with GFDL. So, and then apart from that, yeah, physics items were discussed. Mike discussed about physics parts today. So, and the coupling, Hinsuk is here. And JEDI, yeah, this is an outstanding issue that we will be hashing out. Probably last slide from Frank will also mention how the directions to go. So I'll postpone this or to the next slide probably. So yeah, this is something that I thought we may need some discussions basically and spread it across for next few minutes. I divided the expectation and challenges into 4 parts almost. The first one is, of course, the developments that we discussed in the previous slides. The second one is HPC. Thanks, Radhika and Frank, for attending this. This is very, very timely for us. The third one is forecasting needs, basically, and we discussed about ensembles, and I think there needs to be some discussions on that, basically. And the fourth one, and up till from 6 to 9 is that one. And the last one is other items that we discovered as from various talks is track, wind, precipitation. We hardly focus on rainfall. That's one comment that came out. And the last one was new observations for DA that came out from Josion and others actually, and needs resolution on DA. So with that, the first one, what we want to discuss here is 6 kilometer basin with 2 kilometer multiple moving nests possible for HEREX next summer? What about high resolution ensembles is the first question. And the related question is 6 kilometer global DA or regional DA at 6 kilometer sufficient for hurricane application? So first, let's finish the first questions. Zach, do you want to go? Zujin or anyone?
Yes, I mean, it depends on the development, and I just have a conversation with Gus, and it seems it's possible for the real time, of course, but if we're thinking about the implementation for the version 3 or operational system, we still have lots of issues to be solved. And about the higher resolution ensembles, it depends on our cloud resolution, cloud resources. And it is possible to go with like 3 kilometers. We have two choices. One is 3 kilometers total single domain. Another is the same, the basin scales 6 kilometers with multiple moving nets. That's two choices, depending on computer resources.
If I could just add there, I think we do want to pursue one of these options, either a slightly higher resolution uniform nest or adding the 2 kilometer nests for HERC next summer. I think in either case, we'll likely need to reduce the number of cycles from 4 times a day to 2 times a day to reduce our expenditure a little bit. But we're definitely looking into that, and we're definitely working with Radica already. Oh. Okay. Okay.
Hello. Yeah. So yeah, for the ensemble in cloud. So this year we run this like a 4 cycle in a day. It's quite stable. So if next year we have higher 3 kilometer, so we'll just say we can try to reduce to 2 cycle. Then we can split the members. So we can still have 21 ensemble members. So then we can guarantee we can deliver on time. So so for the multiple moving nest, so we have not started to test it yet. So before we run the real time, we need to make sure it's stable. It's too much crash, we cannot afford it, right? So the energy guy asked, okay, I talked to one this morning, so they plan to pull out the data from the S3 bucket in real time. So we have to promise this. Yeah, that's what I have. Thank you.
So we have a lot of data, but have we looked at it all yet?
Wallace?
Yeah, I was just going to say, before we get super sophisticated, like with HERC, we should definitely go back and look at like, how did it do with respect to the GEFs in terms of error spread characteristics? That might give us some ideas about how to optimize it.
You said we need to compare it with GEFs.
I'm just using GEFs as an example, but
Okay.
some kind of baseline ensemble system.
Yeah, because we haven't evaluated this basically as such. So yes, and is there a team that's going to look at these data sets? I mean, I was personally interested in looking at this, but then yeah, okay. We'll go back to it in the last slide anyway, as Frank said.
Yeah, quick comment about multiple nests. So yeah, just the vision that we're going forward with is having a static domain that covers one basin, say the North Atlantic, and having multiple nests in that same basin, doing something similar for East Pacific or any other basin that we're interested in. We are limited by the projection. The ESG grid can only be so large. So right now, we cannot make the grid, the parent domain, as large as what we did in basin scale HWRF. So we cannot cover the entire NHC area of responsibility. So that is a little bit of an asterisk as we go forward. So our approach is going to be doing these basin-centric domains to start out with. And so that's what we're hoping to test in real time this summer. And any way we can hook up with what's happening on the ensemble side or the DA side, we're going to explore that as well. It's probably going to be too expensive to run HERC with multiple moving nests, but offline, we'd be willing to test something like that as well. So I think what we're trying to put together here is not only pushing the multiple moving nest, but thinking about how we can phase with other developments that are ongoing as well. So we're trying to keep both in mind as we go forward, and definitely open to ideas and suggestions at this point.
I think as we progressed, as I mentioned, we started with this GFDL approach of having one single, one domain at 54 kilometers, and then we did it at 27 with HWARF. We have continued doing that. And I think we need to move out of that strategy for several reasons, not only for multiple moving nest, but for other products. DA system, and what I'm seeing, DA system mainly, what I'm seeing is a sweet spot as emanated at 6 kilometer resolution, which DA is being done, and then I think global analysis is being thought out to be done at 6 kilometers. So let's try to utilize that 6 kilometer spot to do various other, then that's the vision. But then do you want to talk, say anything about the DA, Jason, 6 kilometer DA?
I propose a tweak to item 2.
What's that?
I propose a tweak to item 2.
Okay.
And my tweak is, and this is really after a conversation with Daryl and others, is perhaps we should explore what the global system can do to make our job on the hurricane side easier. And I'll give you an example. Daryl asked me, but what can you live with from GDAS, from the GDAS ENKF members? At what point, does the GDAS ENKF become sufficient for the hurricane application so that we, get around the need to run our own self-cycled system in HAFS, right? Because then that makes life easier for everybody. There's not, it reduces the complexity of what's going on, at INSEP. So, I think, I know you have a purpose for that wording, but I think there's a broader question of what can change on the global side so that we can do our job easier.
Yeah. And the second question is, because we are talking about 1 to 2 years, what is that we can expect next year? Because Zach is already running some kind of 6 kilometer DS system, right, Zach? Yes.
This is 1 to 2 years?
Yeah.
Oh, sorry. I'm thinking like the word.
Yeah, no, no, I saw that. But then how do we, yeah, that's also, yeah, we are putting a strategic plan, but this one is for developments related to what we do for HFIP next year, and then operational implementation. But
for those online, my thoughts were like in the more to the next 5-year time frame.
Okay. So Zach, do you want to comment on what you want to
just
do?
comment on the item 2. I mean, when we're talking about the 6 kilometer global DA system, it could be like, I mean, at least 5 years, because we have to, I mean, the global transition from GSI-based DA to JDI-based DA must have to happen first. Then we can talk about the 6 kilometer GDAS systems. So JDI transition must happen before this 6 kilometer global system, DA system. So it will be, we are talking about 5 years, probably.
Okay. So first, what you're saying is first we'll have a system which is 6 kilometers at least that you are already running. First. Okay.
Yeah. I think this idea is open to discussion. We shouldn't wait JDA transition before we move forward to this 6 kilometer global DA. I think this is, yeah, no, I understand. This is like if the current system can run 6 kilometer, then we go ahead and run it. But if resource not available, then that's out of question.
Yeah. Yeah.
So the context of doing 6 kilometer global DA for GDAS is more in line with GFSV 18, which is around 5 years from now.
Okay.
So, and also Right. And also Jedi transition is also on target for GFS V18. And I would say for us as well as for the global guys, for the global applications, and for other UFS applications, Jedi transition needs to take a priority before we start exploring some of these expensive, very expensive, and futuristic configurations for DIA.
So which means I'll remove this, and then for short-term implementation, do you have a plan? Because I think Zach is already running. That's what we want to recommend, a regional system. Do we recommend that 6-kilometer regional system so that other people can at least do experiments with this? For example, the basin that we are suggesting, is that a pathway that we may be able to take with the same system?
It could be longer term. I mean, you can do the real-time experiment for the operationalize. Probably we have to wait.
How do we get there?
Frank, grab the mic that's next.
Exactly. That's the point, Frank. What do we
Yeah,
do
so-
next real time?
Yeah, well, what I just said, I'll repeat. From what I've heard, there may be a convergence in about 5 years, like when we do V4, V5 of HAFS, and that we should be setting the table for that. And so, after we discuss this, I have 2 suggestions of how to accelerate procedure.
I would recommend we either move to other questions later or table this for an offline discussion or something of that means, because we've got about 40 minutes left.
Yeah,
And there's
well,
like 9 more questions.
Yeah.
Well, I tried to I cut out 2 of them, so Gopal had more, so.
Yeah, you can have one more comment, because I blocked them up into the next part is completely dedicated to ensemble. So it'll be all related anyway.
Maybe this was somewhat related to longer term. I think overall the GFS, the EMC survey in the future is continuous cycling the data assimilation global, like hourly cycling. That takes some time. But in terms of any global DA, I think that's dynamic physics development. It's not say you have a model is running, you just go run it. For 6 kilometers, there's going to a not physics development as well, because it's really going to a gray zone. We need to not just check the topics, we need to check the middle latitude, the Arctic region as well. So we need to say, whenever say you want to move a higher resolution, we need to test physics, dynamics, and over the globe, not just a limited area.
Yeah, but then forecasters are not going to wait for improved forecast for 5 years. So we need to be conscious about what we can do within that time frame as well, basically. So we need to come to a sweet spot wherein what we can do. The last one, probably.
Yeah, just a quick comment on that. So from the HAFS basin development perspective, we're trying to take all of these approaches into account. So in the short term, we're developing what we're calling the traditional VIDA that's going to be based more on storm-centric, and we'll paste everything into a larger domain. I'll spare you the details, but ask me if you're curious. But we're also opening the door and making sure we put in the hooks so we can start to bring in, a large-scale DA that's run over the basin and initialized from that, or maybe run with the HAFS ensemble to get, cycle DA. So we're exploring these things, and I think we're just keeping our options open right now so that we can be as flexible as possible depending on how and when things are developed.
Thank you. Okay, Avichal, and then time.
Let me try and wrap this up.
Yes, sir. Thank you.
Yeah, let me try and wrap this up. So we have some, things cooking for V2 in context of DA. One of the things which I think I talked about it in my presentation on Tuesday, is we want to adopt self-cycle DA. We saw a lot of advantage of doing that with HWARF, and we are not doing that with HAFS right now. So that is something which we definitely want to do it for V2. Then the 1.1D experiment, which we ran this year, will tell us we have not had a chance yet to fully evaluate that and compare it to the initializations which we are getting in HAFS V1. And that would tell us how well that scheme or that method worked and what tweaks are needed. So we may need to, and this is something we haven't discussed, but that we may need to repeat that and get better performance out of that for, say, the real-time experiment next year. That also feeds in as to what Gus was saying in context of building the hooks for the large domain with multiple nests. Possibly, if not in real time, we can do that on the side and check to see how the performance goes with those configurations. My basic point is that there are other things which we can try. I also talked to Jason a little bit about multi-scale DA, introducing that into HAFS.
Yes.
So there are things, these are these low-hanging fruits which we can still work on. But in terms of, having wholesale change of our DA strategy,
Yes.
I think we are better off talking about JEDI transition first and then thinking of this.
Good. Point taken. Work with what we have. That's what you're saying. So yeah, with that, probably we have, the last one, last question.
Okay, so I have to say, you guys talk about the Jedi, then you totally forgot of the Marine Jedi. I know, but Jedi, our Marine Jedi can be in real. No, it's not slide.
No, the previous slide, it was there. Yeah,
Oh,
yeah, yeah. Yeah, the previous slide was there.
yeah, all right, so.
Yeah.
Oh, he skipped over, that's why I did this.
The previous one also had it.
But I want to make sure that the ocean, no, there's no ocean DA. Couple it. That means you are talking about this.
Yeah, that's on the left side of the slide on the bottom.
Yeah.
No, it doesn't say Marine Jedi. I'm talking about I'm not talking about the Jedi.
You've already got the Jedi.
Yeah, I think we, in the interest of time, can you yeah. Yeah. These slides are open. You can change it. So yeah. So the next few, of course, HPC we have already discussed about. Thanks Radhika for and Frank for giving an extensive. It appears that certain things are still. No, certain things are. So I'll move on because certain things are already possible. Ensembles we have tried basically, and probably running the moving nest. Probably we decided it could be run by two cycles. Probably the resources are going to be, hoping that the resources are going to be there, which I think next year it's going to be there. So that part is taken care. Now next, let's move on to the most important discussions that we started having. Not that the developments were not, but these have been ongoing. But the new thing in the fray is our ensembles. And there was a lot of interest from NHC yesterday. There were discussions on that. So I thought a few of those points, does anybody want to start off on the first one? And what do you see as the interest in? All of them are linked. Yeah. Yeah. So, yeah. Do you want to comment on that? Continuation of that project?
Sure, I'll at least start it off. What I'm going to say touches on a few of these things. So I'll start it off and people can respond. So our job is to minimize death and destruction, right? That's what we do. The way I look at this, what causes death and destruction? It is a swath of winds over water and over land that drives, the wind itself, of course, damages things, but the wind also drives the water, surge. And so in terms of like, and if we say there's a 20% chance of something happening based on model guidance, we need there to be about a 20% chance of it happening because that our credibility depends on it. So in terms of ensembles, I think it's making sure that when we communicate a certain likelihood, it doesn't have to be a number, it could be likely or, whatever. But we want to make sure that that number is representative of the actual risk. So I think a few things. The structure, like that swath of winds that's so critical, the radii, we need to start routinely verifying the radii, and probably start looking at things over land even more, because that's where the death and destruction happens. Both rainfall, not just winds and surge, but rainfall as well. And yeah, I think that's a good way to start it off, but that's all I've got to say for now.
Thanks.
I'm going to add one thing to back up what Wallace just said. It's not possible to do the things he described with a deterministic model. And that's why number 6 is where it should be on the top of that section.
I was going to put that, but then I thought I'll finish up with the developmental issues and then go on to that. Yes. Yeah, Zach or Kate? Kate. Yeah.
I was going to say, in addition to this, I don't see it explicitly on here, is the data mining of the ensembles for best usage. Okay. Yeah.
We have covered.
Because it's, yeah. Yeah. Yeah, because we need novel approaches to the use of the ensembles to get the most out of them.
So actually, this is a question for Wallace and Dave. So we already provide all the ensemble products on our website. I don't know, if you look at it, do you satisfy all these our ensemble products, or do you have any requirement for us to develop further ensemble products?
Yeah, so first thing I'll say is I think there are probably some other Hurricane Center folks online, so raise your hand if you want to comment. I don't want to speak for everyone. But I think a lot of us have looked at the webpage, have looked at the products, and a lot of them, assuming that they're skillful and reliable, would be helpful in terms of quantifying the uncertainty of that swath of winds that we're forecasting. So I think the data is there. It's really about optimizing the ensemble system to make sure that 20% chance means 20% chance. But
the other thing I'll add is the website is great for this stage where it's like, hey, we got some money, let's try to throw something together and put it in front of a forecaster and tell us if it's useful. But what we don't have on there, and actually kind of gets at what Kate was talking about too, is I think the wording I used was it's AWIPS or the road on Tuesday. And that might be a slight exaggeration, but we should probably start thinking now about how you're going to present that ensemble data in terms of not a web display, but something that we can put in AWIPS, and then the local offices will equally have it. We can use it to actually make warning collaboration decisions with those offices in the platform that we're using. And a starting point is just basic wind speed probabilities, but there's probably more that we can do. I mean, eventually we're going to be doing all of our forecasting, not just the warning part, but everything in AWIPS. And there may be a day where the forecasters really aren't using the web a whole lot. So I do hope we build that in from the beginning, especially since AWIPS is set up in such a way, with the Weather Service expanding use of the cloud, that anyone can get on there now, especially anyone inside of NOAA can certainly get on there and start throwing data in.
Thank you. But before anything, a cautionary note is that these resources are again dependent on what Radhika has. Basically, next year, I think we have. So do we need to build a plumbing right away from the beginning to AWIPS when we plan the plan? Okay, I heard you. Okay.
Yeah.
Ben?
I basically try to think it the same way Gopal was asking. So we're basically talking about this in real time or running on the AWS. It's not an operational setup for the hurricane system, ensemble system. I think I echo, we have a big gap here for operational ensemble HAFS system with higher resolution. Rufus is already going there, but HAFS, we are not there yet.
Yeah, another back there.
All right, so this is where my detail comes in handy, guys. So actually we are discussing of two different things here. And we need to be cognizant of that. I think what Wallace was talking about was essentially the science improvements we need in our ensemble guidance. So when forecaster puts out 20%, yeah, it better be 20%. So it's and then in the context of providing probabilistic guidance via our models in which the forecasters have confidence. That's a science issue which we need to pursue. The other aspect, which we were discussing in the second part of the conversation, is on the product side. That's a separate issue. Exactly. And what is possible in AWIPS? That's one question. And on that, I know that it's not just NHC. All centers are thinking about what is possible via AWIPS, now that AWIPS is on the cloud, AWIPS 2. And here, we will have other customers, especially if you're talking of ensembles and if you're talking of surge. All the coastal weather forecast offices are interested in that. They want that information. OPC also may want to know that information. NOS definitely wants that information for their ports forecasts. So there are going to be other issues in context of what kind of products we can generate. And one sense is to generate those products to evaluate our science. And I think that our webpage is dedicated more on those lines. But then what products we generate and provide to the forecasters and to the decision makers, that is a separate issue. And that will also require a lot of investigation. And we talk about it in our HFIP objectives as a separate issue. And that's where, again, ML and AI-based techniques are being looked at a lot to come up with good probabilistic guidance.
Yeah, this is Wallace again. Just to kind of bridge the gap between those two things that Avichal was talking about. John Martinez, who's here in the room, he's the HFIP model diagnostician at the Hurricane Center, funded by HFIP, working with Sierra, and just in the very early stages. But he's taken some sample HERC data off the cloud, and he's starting to prototype some products that ultimately could be in front of forecasters. So we're starting to explore the ways to get toward what Dave was talking about. Very early stages, but we're starting to think about that too.
Okay.
So
nice. Okay. So we will continue on the scientific whenever resources are available, depending on it. We'll continue on ensembles with focus on science. HFIP is bothered about that as well. Is focused on that as well. So with that, any other what diagnostics? I think it came across. Probably we can quickly go to 8. What diagnostics can HAFS provide to forecasters beyond location and maximum wind? Those are probabilistic products basically, and I think Wallace said already it's the winds and wind swath structure. So are we there with it, Zach? So from this year, what did we get? Yeah, any inputs on that? Are we there with what NHC requires from scientific point of view? What is required if we run ensembles next year?
I don't know what's required, but I'll tell you about a few things we've been working on that you know about, Gopal. But we're really thinking about how we can put the model output side by side with observations that are collected from the Hurricane Field Program and outside of the field program too. So we've invested some time and effort in putting those products out there. For example, comparing the TDR to the simulated radar reflectivity coming out of HAFS. Another thing that's sort of on our horizon that we're thinking about in conversations with NHC, Wallace has been very helpful sort of framing this for us. But on the ensemble products, we can get started right now thinking about our 4-member hurricane ensemble with HWRF, HMON, HAFS A, HAFS B, and start. I know it's only 4 members, but start to think about how we can display the information from multiple members, whether even if they're from different dynamical cores and stuff, and pursue that. And, you know, one thing that just came to light from this meeting that's pretty obvious, but giving the range of possibilities. We're obsessed with these line plots that are sort of connecting the lead times from left to right, but maybe we need to sort of think about something that's familiar, but reframe it so that the forecasters get an idea of what the range of possibilities are and what the PDF, if you have enough members, are in that range. So these are some things that we're thinking about that ties into, you know, ensemble products. And by the way, this is Gus Alaka, attorney. This is the first time I said that today.
So your question is like, what is NHC's requirement? And I'm just going to steal this from Philippe, who put it in the chat, but not everyone here is seeing the chat. I think our top priority is making sure that the ensemble, you know, spread is appropriate relative to the expected error. If we get a bunch of cases like Lee, where the entire ensemble forecasts something, then you get something that's very different. Forecasters aren't going to use it. I mean, we can tell you things that would be nice if you had a good ensemble, but if the ensemble isn't tuned appropriately, it doesn't matter what the products are. So I think from an NHC perspective, that should come first, is scientifically getting a ensemble that captures the range of possibilities and is well tuned.
Okay.
So then,
good job.
oh, okay, good, nice. So and then
Gopal, can I?
Okay.
So Kate Musgraves here. I don't think I've remembered to announce myself yet either. One of the things that we're working on that came up earlier this week that is just getting underway is really trying to build a detailed surface wind analysis. Now, whether that's just from observations with maybe some background theoretical models underlying it, or we're getting into something where we're gathering data sets and doing advanced DA to try and build an analysis of record. I think that that's something that we really need to get a move on doing that, because it underlies a lot of things, including the discussion of the WSP 2.0 and really what should we be using as ground truth in evaluations, as well as what should we be initializing storm surge models and whatnot off of. So that is work that just getting underway with the storm surge unit. But that opens up the possibility with HWRF in the shorter term that we could really get a Tiger team started and pull knowledge and data sets and everything out there right now and try to work together as a community for building this.
Yeah, I have 4 more minutes, so I would quickly go on to the next few items. Probably if Wallace, you're okay with the ensemble discussions, we can move on to other parts. There were also notes, for example, I think Dave that mentioned, and from the community, is localization and, for example, land surface when you have rainfall, and that's where localization and better visualization of products came into being. Basically, any discussions that anyone wants to take over briefly.
So for the localization, like especially for land for storm, right? So we come back to ensemble again. Sorry about that. Okay. So the social science, they want us tell them like what's the diversity. So what's the probability this storm is going to land in Miami or in the west coast of Florida? Those probability will guide the social science, so they make a plan. So for evacuation, those things, those are very local stuff. Right? Yeah, that's what I want to say.
Thank you. And of course, when I put this, probably I didn't hear to Wallace's talk today morning. So that's an addition to what we put here, basically the winds at local level that you're trying to do. So that's one thing that we. And then last 2 quickly, I want to go through to hardly focus. Yes, rainfall, precipitation is not. Yeah, but then I'm going to leave the last 15 minutes. Yeah, the last 2 items quickly. Precipitation is something that
this is arbitrary. Yeah, so one other advantage of my detail is that my office is right next to Jim Nelson. And I've been discussing a lot about precipitation and rainfall with him. His favorite topic. Yeah.
Yep. Yep.
So Jim actually, in one of his slides, did show us how HAFS did, at least on the preliminary analysis. Not exactly sure how much of HAFS data he used for that result, but it looked good. Okay. I see. Okay, so you know better. But Jim and WPC in general are interested in doing a post-mortem of HAFS-A and HAFS-B precip forecasts for this season. It'll take them a few months, most likely after the winter is over. So it will mostly be more likely spring of next year when they will have their analysis or the postmortem. But to address your question on the rainfall, we will be getting some very useful feedback on HAFS V1 by, I think, spring of next year.
Great. Thank you. Yeah, and the last one is new observations. Yeah, you have a question, and then probably I can move on to Frank again.
Hi, this is Brian Cole with the UXS Research Transition Office. For the new observations, I just wanted to point out maybe or raise the idea for the next strategic plan that we've got 3 really nice concepts of observation gathering with UXS, with buoyancy gliders, surface vehicles, and air-launched UAS, none of which have a path towards regular use or operations, either funding-wise or I think even testing and evaluation-wise. So I would encourage future strategic plans to look at how are we going to evaluate those, how are we going to decide which ones meet whose requirements, and how are we going to pay for those sort of things if we want to keep having those observations in future seasons. So I'm not sure if that's the exact right time to bring that up here, but since it said new observations, I figured I'd go for it.
Yeah, sure. I thought Joe was also going to say the same thing, probably. Okay, okay. That was meant for when. Yeah, you go ahead.
So a quick comment on precipitation. We've heard a lot of praise for the probabilistic wind products. For the HAFS ensemble, we also debuted this year a probability of different precipitation thresholds. Now, obviously, getting back to Philippe and Wallace's point, we'll need to go back and verify if those probabilities are well calibrated, but I think it's a good first step.
Good. And I think, Joe, do you want to go through the last one, and then I'll let Fran take over? On new observation, do you want to have any comments on that? Yeah, Joseon.
Can you read the question? There we go. It's a little small, Mike.
New observations for DA and model improvements.
I would just say, being able to continue and have more resources. I've been on the DA side working primarily with Jason Sippel, and we're just kind of doing it ad hoc, I don't think we're funded. Where's Jason in here now? But yeah, so we're technically not funded anymore. Is that right for the DA? So that would be helpful. That would be nice to actually get some DA money for the new observations. Yeah, put it on eBay. Let's get it going to the first bid.
No, isn't that our MO, unfunded work?
Yeah, exactly right. But we're trying to change that. They're asking for suggestions. So suggestion was to actually fund it. That would be good. We
Transition office needs to fund the DA. Stop funding the equipment and fund DA.
stop funding the equipment. Hold on over there, cowboy.
Hey, Joe, I just want to pop in real quick. This is Aaron. There was a comment earlier from John Knapp, basically saying, I hear you, Wallace. I really think it should be part of this is that HFIP should be a part of improving observational network in coastal areas. Because he had gotten caught off the other day when he brought that up. For instance, well-sited mesonet that could provide winds, gusts, rainfall totals and rates, et cetera. Yeah. Would help with not only model verification, but also monitoring of landfalling. So just since you guys were talking ob systems and so forth, I wanted to put that in there.
Yeah, and Frank, how do you assimilate if you don't have an observation? Just for the record.
No, it's great discussion. And I think you've all caught up to where I was. Next slide, please.
Give me a minute.
Okay. So I have a couple of proposals that I thought of based on this discussion, but also what I heard. I think we need to take some actions. I think we need at least 2 Tiger teams. And I'm going to ask some people to take in charge. One is the HAFS-DA JEDI transition. We heard from Daryl that there are implementation plans for GFS and for Rufus, not for HAFS. They're willing to share their ideas, and maybe if we work with them, we'll get a transition plan for ours that takes advantage of their efforts and some of ours. So I'm going to suggest that we have a HAFS-DA JEDI transition team to develop an implementation plan in coordination with GFS and Rufus, DA for JEDI transition plans. I suggest we target HAFS V3 FY25, which is also coincident with the GFS timetables and Rufus's timetables. That's our notional target, V3, hopefully V4 for sure. And I want to leverage it on the JTTI supported DA that we heard about from Avichal yesterday. The Avichal, John Potterjoy, and Juguang already have something to start working with. The question is, should that be our target? But I'll let the implementation plan people do it. I know Daryl has volunteered to be part of that Tiger team. And I'm suggesting Jason Sipple, who I beat on already, and he said yes, be the co-lead and come up with a transition plan for us, put it in our next generation strategic plan. Should they give us their goals and objectives and metrics, and that be added to our plan. Second one has to deal with uncertainty. We heard a lot about, what we already are doing. I mean, Mark DeMaria's group and what Wallace talked about was already going on with the ensembles. I think we need to take advantage of it. I think we need to have a team to develop a proof of concept, provide storm-specific ensemble model statistics to produce the PDFs that they need to drive their operational products. We've already heard they got a wind speed probability. They're going to add gusts to it. They're already using machine learning. What we need to do is provide them data and work with them on how to use that data. I think, we have the WTCM. They're already doing it. How can we help them? We can do the analysis to evaluate how good that is. We need to look at the land surface modeling part because we're over land. But, what can we get out of the model that they can use, whether it be ensemble or dynamical and multi-model ensemble? There's a lot of ensembles out there. I think Jim Gersh made a great comment. Multi-models give you better spread. And we do have a lot of them. We have at least a HAFS ensemble. CTCX has an ensemble. We can make an agreement to work with them. We have GEFs. And we have ECMWF ensembles that we can even look into. So what I'd like to see is that this Tiger team, and I've asked Wallace to kind of be a lead, and I'd like to get a researcher to kind of work with them. And I suspect it might be Kate or somebody from Sierra. But, we heard about DESI and we heard about TCANE. These are 2 tools that we can take advantage of to develop these products. And it's really focused on the goals should be what NHC needs, not on ensemble production and how ensembles work and generating products. Get them data that they want that will inform their uncertainty. So those are my 2 recommendations for actions over the next year. And so, I already have two people who've volunteered to lead. We need members, and I'll let them go after those members, and I'll support them in kind of twisting arms. We have to be flexible. My wife always tells me I'm not flexible, so I do this to her. And she says, no, you're not flexible. But we have to be flexible in making our decisions here. So I'm going to make these two recommendations and let you guys react to them. But I think this is a high priorities. New observations, we're not going to know what to do with them until we get this JEDI transition done. I go back to what Avi just said. This is HAFS V1. Okay? This is what we could do with the supplemental money. From now on, I'd like to see the ramp of the products getting out and stuff like that. So, this is more than a model development effort. This is really a focus on goals that NWS has. And that should drive our needs and goals and specifics. Anyway, thank you all. It's been a great 14 years. I love working with you guys. I'll be here next year if my boss says I can still be here.
So Paul, are you done? Do you have closing remarks or anything you want to say?
No, thank you.
Okay. I just wanted.
Last
oh,
point
you
about
didn't-
the
I'm
ensemble.
sorry, go ahead.
Yeah, maybe add the word verification in there, development and verification of ensemble products before you turn them over to the forecasters.
Point well taken. I just want to add something to what Frank said at the end there. And I've been saying this since I got here, especially since last June when HAFS went operational. And that is, we know what HWRF could do after about 16 years of life before the code was locked. And we're basically doing that plus a little bit here and there at 1 year of life. So let's not think we're not doing enough and we have to move faster. Let's do the right things at the right time. And a lot of that is exactly what Frank said. Supplementals accelerated the early development of making HAFS. We don't have those after next October 1, as of right now at least. So we need to be realistic on ourselves too and not beat ourselves up too much. And I think the only way we're going to get through that is to make sure that we continue to talk to each other like this, not just once a year, but across throughout the year as well. So with that, thank you all for coming. I really appreciate it. I would love to give you dates for next year's annual meeting. Right now, I don't have them because I'm trying to work it around the annual NOAA Fall Retreat for SESers so we can get some of them to show up because there's been interest, which one, unfortunately, this year was this week. Tentatively, I'm looking at November 12th to 15th of next year, but that is contingent on what I hear back from the SES crew. Yeah, I can mention that real quick too. So at our last briefing with the HEOB, with the current two executives that are over top of that being Ken Graham from the Weather Service and Steve Thurr from OAR, they are both extremely supportive of HFIP, its history and its future. They're both very willing to walk up hand in hand, skipping along merrily through DC up to the hill. And they've asked for us to increase the cadence of HEOB briefings to quarterly. I've been trying to do that, but it's very hard to get on their schedules. So I'm working on scheduling out a year in advance to get a whole year scheduled and be able to keep them updated more frequently on what HFIP is doing with all of its moving parts. So maybe reaching out from time to time to get information or suggestions or graphs and charts from folks so that we can present proper updated information when we do get those meetings on the calendars. Yes, very good point, Frank. The annual report for 2022, which also includes 21, which was never finalized because we had issues with getting it approved by the NOAA library, has been approved. It is on the hfip.org webpage. It's listed as annual report for 21-22. It's fully vetted through the NOAA library, has a DOI number, so it is official and can be shared out and referenced. So thank you, everybody, and please travel safely, whether that be local or long distance.